Hello there and welcome to a brand new lesson. This is Hard Beyond Numbers, where we learn maths the easy way. In this lesson, we want to look at linear functions, and by the end of this lesson, you should be able to define a linear function and identify its key features. With its key features, I mean the slope and then the y-intercept. You should be able to write equation of a line given the slope and then the y-intercept, or slope and a point. You should be able to find the equation of the line passing through 2 points. You should be able to determine from a graph or from 2 coordinate points the slope of a line. And finally, you should be able to identify parallel and perpendicular lines using their slopes. Here are some vocabularies we'll be using as we study this topic. Without much ado, let's quickly look into it. And my advice is try your best, get a notebook and then a pen, and also solve the questions as we proceed. So let's start by first of all looking at what a linear function is. When we talk of a linear function, it is simply a function of the form f of x equals mx plus c, whose graph is a straight line. So if you're able to graph any function and then you are getting a straight line, then we say it is a linear function. If we look at the graphs I'm going to show over here on the left side of our screen, this very first one is a linear function. It is a linear function because, as we can see, it is a straight line. A straight line. On the other hand, this graph here is not a linear function. Why? Because it is certainly not a straight line. This as well is not a straight line, so it is not a linear graph. This is also not a linear graph. This is also not a linear graph. All of these you see here are not linear graphs, except this very first one. Now, the other thing you have to note is that apart from it being a straight line, the highest power of x is 1. So that is to say, if I have a function f of x and I have 2x squared plus c, you might say, comparing it to the general form of a linear function, it is what? mx plus c, but that is not true, because the power of x over here should be 1. The highest power you'd ever get of x should be 1, but what we have here is 2. So that is what we call a linear function. Now, for every equation of a line, we write it in a special form we call the slope-intercept form. And when we write a linear function in slope-intercept form, it simply means we have written it as what? Y equals mx plus your c. M has what it stands for, and c also has what it stands for. The m you see over here is the gradient of the function. Now, it simply tells us how steep the line has risen or fallen. Illustrates that, let's look at this line over here. This function that has been graphed is actually x plus 3. So what I'm going to do is, from x plus 3, I'm now going to increase the coefficient of x to be 2. So if I make it 2, you see how the steepness changes. And if I make it 3, you see how the steepness changes as well. If I make it 4, you see how it changes. If I make it 5, it changes. 6 also changes. And you realize that it keeps going up. The steepness keeps going what? Up. Now, what if, rather than in the positive domain, I start moving towards the negative? So this is when the coefficient of x is 1. Now I'm going to make it a negative 1. You see how the steepness has changed. So from the lower left to the upper right, all the way toward from the upper left to the lower right. If I'm to make it negative 2, you see it changes as well. If I'm to make it negative 3, you see it also changes as well. So even though x and then c remains unchanged, if you keep changing the gradient, that is the m of the function, it affects how steep your graph is. Now, the next characteristic of this slope intercept form is what we call C. C is the y-intercept. C is the y-intercept. So for our equation we have here, this that I've graphed, when we talk of y-intercept, then we simply mean where the line touches the y-axis. You know, the vertical axis is the y-axis, and then the horizontal is the y-axis. So if I'm to zoom in, you see the line touches the y-axis over here, and the coordinate at this point, as you can see, is what? 3. This is the y-intercept. If I was to change the equation and then write something as this, so this is a graph of 2x plus 5. So with that as well, if I'm to zoom in, you get to see where it touches the y-axis at what? 5. And that is what we call the y-intercept. So if you're able to write an equation in this form, you are easily able to tell what the gradient is. And you are also able to tell what your y-intercept is. As demonstrated, the value of m affects how your graph looks like. When your m is greater than 0, then you have a line that goes up left. So this, for instance, is an equation 2x plus 5. My gradient m is 2. So it moves what? Up from the left to the right. That is a positive slope, all the way from the left to the right. Now if I'm to make the gradient a negative, let's see what is going to happen. You see, so for a negative gradient, it moves down from left to right. So from the left all the way to the right hand side. But if my gradient was 0, let's see what a 0 gradient is. You see, so if 0 gradient, it neither moves in an inclined plane, but then it is a horizontal line. You see, this is how a 0 gradient looks like. So depending on how the equation is, it might move it up or down. So with all these said, let's look at how to find the equation of a line. Now, there are 3 common scenarios we use when finding the equation of a line. The very first one is when you are given m, that is the gradient, and then c. So if you are given the gradient and then the c, you can quickly write it as y equals, then you take your m, so m x and then plus c. That is all. Now the second scenario is when you are given the gradient and then 1 point. When you are given the gradient and 1 point. So if you are given the gradient, let's say m, and then 1 other point, the point being x1 and then y1. Then what we do is we use a formula, and the formula is written as y minus y1 equals m into bracket x minus x1. We call this the point slope method. The point slope method. So this over here, you are given a point, and then the slope. You see, I didn't mention this. For this one, it is called the slope intercept method. So you are given the slope and then the intercept. But for this, you are given the slope and then a point. So it's called the point slope intercept. After this, we then simplify. Now, if you are actually given 2 points on the graph, then to find the equation of the line, so let's say you are given 2 points. The first point being x1, then y1, and then your second point being x2, y2. Then we use the gradient formula. With the gradient formula, this is where we actually solve for the gradient. You see, so we solve for the gradient and then come back here to use the point slope. Now the gradient is giving us the change in y values over the change in what? X. It is also known as the rise over run. So to solve for it, you see we have two values of y. So we'll find the change in y values, and that is to say change in y is simply the difference between the y value. So y2 minus y1. And change in x is also what? x2 minus x1. Now, if you are using 2 minus 1 for the y coordinate, you have to repeat the same for the x coordinate. You could have as well written it as what? y1 minus y2. In this case, you have to use the same for what? The x. So x1 minus x2. If you're able to get the gradient here, then you come back all the way to this and then use this method. Now, before we begin applying these methods of finding the equation of a line, there are some concepts that are necessary to be understood. These are the parallel and then perpendicular lines. When we say two lines are parallel, then we simply mean they have the same slope. So as you can see, this one is y equals 4x plus 3, and the other is y equals 4x minus 3. This has a slope of 4, and this also has a slope of 4. We say they are parallel. If I'm to give you the graph of this, which is as you see displayed over here, this blue line is the line 4x plus 3. And then this one here is the line 4x minus 7. Realize that they are parallel to each other. You see, so it doesn't matter how far we extend it, they will never meet each other. So even if I'm to zoom out, you see they go on and on and on, even without meeting each other. These are what we call parallel lines. On the other hand, when we talk of perpendicular lines, then we simply mean if you have an equation, so let's call this equation y equals mx plus c. So this is our first one, and then y equals mx plus c. This should be our second one. If this equation or if this function is perpendicular to this, then what it means is if we are to multiply their gradients, we'll get a -1. Or we can say the gradient of one is the negative reciprocal of the other. So that is making m1 the subject. We will divide both sides by m1, and then it is going to be right here, as you see. So these are two conditions you should know. So I would identify these on the graph so that you see what we are talking about. The first one being 3x plus 1. This is 3x plus 1, you see. And for -1 over 3x plus 5, this is it also over here. Now, if you take note of the angle we have here, it is a 90-degree angle. Now, there are so many other lines that are perpendicular to the blue one. But for now, our interest is on this very one. So looking at all these yellow lines, they are all perpendicular to it. Why? Because they touch it at an angle of 90 degrees. That is all. You see? So at an angle of 90 degrees, they are all perpendicular. But this very one is the one that satisfies this equation over here. So with this basic understanding, we want to actually solve some questions. As we always do, we will solve 5 questions that will help us learn on all the concepts we have covered in this lesson. I would advise you take your notebooks and try as much as possible to solve the questions before you look at the suggested solution. So looking at our first question, which is very, very simple, it says, state the slope and y-intercept of each line. So we are going to solve the lines one after the other. For the first one, we have y equals 5x minus 3. Now, even before we start with this, we know what the slope-intercept form of the equation of a line looks like. So let me write that down first. So we know it's giving us y equals mx plus c, where our m is the slope, and then c is the y-intercept. So for this first one here, it is already written in that form. You see, so we know what our m is, our x is here, and then our c is here. You see, so with that, we can say that by observation, m equals 5, and that is the slope. And then c is also what? Negative 3. So our slope is 5, and our intercept is supposed to be a point. Now, on the intercept, the x coordinate is 0. So if c is negative 3, then its coordinate is 0, negative 3. As simple as that. For the second one, we have y equals negative 2 plus 7. So it is negative 2x plus 7. This has also been arranged in this form. Hence, we can easily tell our m. So our m is a negative 2, and then our c is a 7. So it simply implies that our y-intercept, as I said earlier on, the coordinate of x and the y-intercept is what? 0. So we have 0, 7. As simple as that. Then for the last one, we have y being equal to 4. Now for this, we would have to rewrite it to look like this. You realize that it has no m. So if we want to rewrite it, then it is y is equal to 0x and then plus 4. So the gradient is 0. And then its y-intercept is what? 0, 4. Now this line is actually a horizontal line. Now I'll draw all of these on the graph so that we see how they look like. So as you can see for the first one, this is its graph. And if I'm to zoom in, you see we have the line this way. And this is where the line touches the y-axis. And we call it the y-intercept. So its coordinate, as you can see over there, is what? 0, negative 3. In our subsequent lessons, we will consider what we call the x-intercept as well. But that is beyond the scope of this question. So this would have been the x-intercept. That is where the line will touch our x-axis. Let's look at the next one. This is the graph of the second one. As you can see, it is a negative slope. Hence, it falls from the left-hand side to the right-hand side. If we are to zoom in, then we would see our y-intercept, and that is what? 0, 7. Just as we rightly solved over here. The y-intercept being what? 0, 7. Then the last one, which was y equals 4. So this is our y equals 4. It is just a horizontal line. And its intercept is also what? As you can see, it is a 0, 4. Let's look at our next question. Our second question is you have to find the equation of the line with slope 3 and it passes through the point 2, 7. We have the slope. So with this we have m being equal to what? 3. And we have our point. Our point is what? 2, 7. So which of the methods would we use? Since we have the slope and then the point, we use the point slope form. So you start by saying using the point slope form, and we know what the point slope form says. It says we have y minus y1 is equal to our m into bracket x minus x1. So with that, let's take note of what our y1 is going to be and then our x1. So this is going to be our x1 and then this is going to be our y1. Now we do our necessary substitution. We have y minus y1, which is what? 7, is equal to m, which is 3. So 3 into bracket x minus x1, which is also a 2. From here on, we just want to make y the subject. So we have y minus 7. Let's open up this bracket so that I have 3x and then 3 times negative 2, giving us a 3x minus 6. So making y the subject, we have our y, which is equal to a 3x minus 6, and then plus 7. And that gives us a y, which is equal to a 3x plus 1. As simple as that. So therefore, our y is equal to a 3x plus 1. That is the equation of the line with slope 3. As you can see, it has a slope of 3. And then it passes through this point. So with this next question here, it says we should find the equation of the line passing through. We have 1, 4, and then 5, 12. This time around, we've not been given the gradient, but then we've been given 2 points on the line. So what do? We would have to find the gradient ourselves. And we know the formula for the gradient. So we know the gradient is giving us y2 minus y1 all over an x2 minus x1. Or you could have also used m equals y1 minus y2 all over x1 minus x2. The most important thing is you stick to consistency. Let's use this for now. We need to identify which is going to be our x1, y1, and then x2, y2. So with the point 1, 4, and 5, 12, what I'm going to do is, this is going to be my x1, y1, and then x2, y2. So our substitution then is going to be m equals y2, which is 12. So 12 minus y1, which is 4, then all over x2, which is 5, minus 1. Simplifying, we have our m giving us what? An 8 over 4. Hence our m is equal to 2. So with this, you have the gradient and 2 points. So with the gradient in any of the points, you can solve for the equation of the line, just as we did for the previous one. Hence, we would need to decide on which to use. I would be using this one, but if I finish, you should also use this and confirm for me in the comment section if you had the same answer. So using m equals 2 and then x1, y1 being what? 1, 4. Then I'm going to say with my point slope method, which says y minus y1 should be equal to m into bracket x minus x1. Then upon substitution, we have our y minus y1, which is what? 4, is equal to m into bracket x. So x minus x1, which in this case is 1. Then we make our y the subject. So our y is equal to what? Take note, we had our m. So we could have as well just substituted our m right away. So m is 2. So I'm going to get 2 into bracket x minus 1. Then the 4 moves to the other side to give us what? A positive 4. Simplifying, we have 2 times x, which gives us a 2x. Then 2 times negative 1, which gives us a negative 2. And then we have a plus 4. So our y is equal to 2x. Then negative 2 plus 4 gives us a positive 2. This is the equation of the line that connects these 2 points. What did we do? We decided to find for the gradient. And we know the gradient formula is what? Change in y values all over change in x values. After which we then use the point slope method. So if we have our gradient, then all we need now is what? One of the points. So you could have used any of these points to generate your answer. Let's look at our next question. That is our last but one question. Question number 4. Our next question we have here says, a line L as equation 4y minus 5. We have to find the equation of the line that is parallel to L and it passes through the point 0, 3. So first of all, we know the line y equals 4x minus 5 has been written in the slope intercept form, which then implies that our gradient is what? 4. And our y-intercept is what? 0, negative 5. So with this, we want the line that is parallel to L and then we'll pass through the point 0, 3. How do we get that? We know for parallel lines, their gradients are the same. So if we are to name this gradient as M1, we would write that let the gradient of the parallel be M2. And if it is really parallel, then it simply means M1 is equal to M2, which is equal to what? 4. Now, the point we're given is 0, 3. So using our point slope method, we're going to write using y minus y1, which is equal to m into bracket x minus x1, where x1, y1 is the point we've been given, that is 0, 3. So doing our substitution, it means we have what? Y, then minus y1, which is going to be what? This 3 over here, is equal to our m, which is 4. Then into bracket x minus x1, which is going to be this 0. Simplifying, we have y minus 3 equals what? 4x. We know x minus 0 gives us x. So just 4 times x, giving us 4x. Making our y the subject, we have 4x, then plus 3. This is the line that is parallel to this line. Then it passes through this point. And that is just it. So to get or find the equation of a parallel line, the most important thing we need is the gradient. If you have the gradient from the other line, if you are given a point, you just do the needful. The second one says we want the line that is perpendicular to L, but then passes through this point. Once again, let's let the gradient of this line here be what? M1. And with that, let's let the gradient of the perpendicular be what? M2. We can let it be M3 since we have already used M2 to be that of the parallel. Now, if it is perpendicular, then it simply implies that the product of M1 and then M3 is equal to what? -1. Remember the condition. It's either you use this. It's either you use this or you go straight forward and say M3 is the negative reciprocal of the other. So in this case, we know what our M1 is. Hence, we have 4 M3 being equal to what? -1. Making our M3 the subject, we are going to divide both sides by what? 4. So upon our division, we have the gradient of the perpendicular being what? A -1/4. So with that, we have the gradient and we also have the point 0, 1. We are going to use the point loop method once again. So we have our y minus y1 then equals our m into bracket x minus x1. Doing our substitution, we have y minus the y1 here is 1. So 1 is equal to our m, which is -1/4. That is what we have solved over here. Into bracket x minus 0. So we do our simplification. We have y minus 1 equals x minus 0 gives us x. So we just have our -1/4x. Making y the subject, we have a y which is then equal to a -1/4x. Then the -1 moves to the other side to give us a +1. And that will be just it. So this here is the equation of the perpendicular line to the line we were given. Very simple. So to solve for perpendicular and parallel, the most important thing is we being able to identify the gradient. Parallel says the gradients are the same. Perpendicular says the product of the two gradients, that is the one of the reference line and then the perpendicular line, should give you what? A -1. After which you then make your gradient M3 or whatever you have named it, the subject. Let's look at our last question for this session, which is going to be a word problem. Our last question here, as you see on your screen, is a word problem. It says, a delivery company charges a fixed fee of 12 cedis plus a 5 cedis per kilometer. We have to write a linear function for the cost in terms of distance, that is A. Then B, we have to find the cost for 8 kilometers. Then C says we have to, for what distance does the cost equal 47 cedis? Now this has to do with modeling out your equation from the word problem. If you read carefully, it says there is a fixed cost. There is a fixed cost. So a cost that does not depend on the distance you have traveled. A cost that does not depend on the distance we have traveled. So that is, even if distance is 0, you'd have to pay that cost. So that should give you an idea of what part of the equation that is. Before that, let's identify the dependent variable and then the before that, let's identify the dependent variable and then the independent variable. So for the distance, it doesn't depend on anything, but then it is the cost that depends on something. So A, it is going to be the cost function, which depends on the distance. It is going to be what? Equal to, it said, a delivery company charges a fixed fee of 12, then plus, so first of all, it is going to charge 12, and then plus 5 kilometers per 5 cedis per kilometer. So 5 times the distance. You see, so if the distance is 1, then it's going to be 5 times 1. If the distance is 2 kilometers, then it's going to be 5 times 2. If the distance is 10, 5 times 10. You see, so with this, we can rewrite it as 10. We can rewrite, so with this, we can rewrite it as 12 plus 5d, which then can be rewritten as 5d plus 12. So this is the equation that represents the charge of the company, and it is a linear function for the cost in terms of distance d. That is the first part of the question. The second part of the question says, find the cost for 8 kilometers. It simply means our d now is becoming what, or has become 8 kilometers. Substituting, it simply means the cost at 8 kilometers is going to be what, 5, then times your d, which is 8, then plus 12. We have 5 times 8, which gives us a 40, then 40 plus 12. This here gives us a 52. So the cost after traveling forward 8 kilometers is going to be what, a 52 cedis. Then the last part of the question, it says, for what distance is what? For what distance does the cost equal 47? For what distance is the cost equals 47? We know our function is given as what? C of d equals 5d then plus 12. Now the cost depending on the distance has now become what? 47. That is to say 5d plus 12 is equal to 47. So 5d plus 12 equals 47. Then all we need to do is to make d the subject. So we have our 5d, subtracting 12 from both sides. We have 47, then minus 12. We have our 5d giving us 47 minus 12, which is a 35. Making our d the subject, we would have to divide both sides by 5. So divided by 5, divided by 5. Hence we have our d, which is equal to what? 7. You see, so what is our conclusion? It simply implies that it is at the distance of 7 kilometers that you'd be charged what? 47 cedis. So we can conclude by saying, therefore, the cost function is what? 5d plus 12. Then 8 kilometers costs 52 cedis. And then 47 cedis is charged at 7 kilometers. So that is all for the set of questions we have for this session. But as usual, I'll leave you with some exercises so you try on your own to test your understanding. So here you have 5 questions, just as we have solved. You can go back and then quickly revise and then come back to try and then solve them on your own. This is how Beyond Numbers will learn maths the easy way. If there's any issue of concern with regards to what we have studied, you can always let me know at the comment section. See you in our next lesson. Bye for now and do stay blessed.